stuff, new stuff, new stuff, new stuff. Okay, good. All right, good. Glad we're all excited for today. So, guys, we're talking about operations with exponents. Operations with exponents. We're talking about exponents today. You know what? Do you know what the number over here is called when you see it? It's called a base. And when you see an exponent, is an exponent really big or really small? It's a small number, and it's typically up over here. Are you guys good? Good. Whoa, 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 whoa. Stop screening. So there's gonna be two categories here in your notes. One category is gonna be like just operations. And then the second category is going to be examples. So you'll get to see examples of what's going on. And the first one is going to be addition and subtraction. Addition and subtraction. So what happens when you try and add two things that have some exponents to them? No, you do. I mean, like, yeah, you do have. That's like PEMDAS. I'm talking about like, well, how do you like today? Our discussion centers on like adding and subtracting things that have exponents, multiplying and dividing things that have exponents, raising things with exponents to other exponents. And take a look at our first example. So addition and subtraction. You see on the right side, 2 squared plus 2 cubed. Right? What do you do with that? Do you add the numbers on top? Do you add the numbers on the bottom? What do you do? Nope, you just evaluate them. And you can only combine like terms. Like that first one. Does anybody know what 2 squared is? What's 2 cubed? Nah, chill. Not 6. Yeah, 8. 8 because 2 cubed is 2 times 2 times 2. So the first one is going to be 4. And the second one is going to be 8. You know what 4 plus 8 is? 12. 12. And how about that second one? X cubed minus x squared. Are those guys like terms? They are, aren't they? Why so? For two things to be like terms, Alexis, their x's must match perfectly. So x cubed and x squared, are those perfect matches? Are they like terms? It's like one's a cube, right? And one's a square. They're not like. So when you try and add them, you can't add these two things. They just are, they just stay just like that. They can't be added. They're not like terms. That's weird, I know. So we learned about addition and subtraction. Now let's take a look at what happens when you multiply two things that have exponents. What do? Powers of like exponents are added. You know what 3 to the 4th times 3 to the 5th is? You're the man. You are the man, Eric. 3. Whoa there. Yeah, this is 3 to the 9th. Yep, 3 to the 9th. Let's play again one more time. What about x squared times x to the 3rd? How much do you think that is? Alexis. X to the 5th, excellent. Yep. And how about x to the negative 4th times x to the 5th? Very nice. X to the 1. Great job, Jessica. Great job. X to the 1. Yeah, it's the same thing as saying x. Perfect. Okay. Guys, now we talked about multiplication. You add the powers. What do you think happens to division? Division is the opposite of multiplication. What do you think you do to the powers? You subtract them. So 4 to the 7th divided by 4 to the 5th equals what? 4 to the... Nah, chill. Nah. 4 to the 7th divided by 4 to the 5th. You subtract the powers. 4 to the 2nd. Very nice. Yep, you subtract those powers. We got to talk about one more, right? It's not that easy for everyone here. What about x to the 3rd divided by x to the 8th? What do you think that is? Very nice, Vanessa. Great job, girl. X to the negative 5th, because 3 minus 8 is negative 5. It's excellent. Way to go. So now this is the one where things get confusing. Raising a power to a power. What you do is you multiply the exponents. And people in the past make fun of me because they say that This is like something that's not meant to be, not meant to be as I say it. Take this 3, make it rain. Make it rain, I mean, the 3 drops down. You know, like dropping a free throw. It drops down inside, multiplies all the numbers. Yeah, it drops down inside. You see that? That's a bad arrow. Yeah. Yeah, exactly. It is 5 to the 2 times 3, and that's the same thing as 5 to the 6th. Now, some people in the other class were like, what? I don't get it. And that's because, take a look. Another way to think of it is that when you raise something to a power, that's the number of times it is multiplying itself. So this is the same thing as saying 5 squared times 5 squared times 5 squared. Right? Oh, man. My computer's just being really slow. And that's what that is. Ultimately, you'd get 5 to the 6th out of that. Take a look at the next one. X to the 4th cubed. What do you think that is? Very nice, guys. Yeah, x to the 12th. That's x to the 4 times 3. Yep, make it rain. Make it rain on that number. Yep. X to the 12th. All right. We are on to number 5, right? Raising a fraction to a power. Here's what you do. When you raise a fraction to a power, you raise the numerator and the denominator to that power. So it's like this 2 out over here. This 2 out over here is going to get distributed inside to both of these. Look at that. It's just pouring. It is pouring. So let's talk about what this means. This means that this becomes 3. Whoops. That's a terrible 3, but you get the point. That's terrible. I can't have that. It's too messy for me. Right? This is going to become 3 squared over 5 squared, which is 9 over 25. Yep. Guys, let's talk about this other one, right? Let's talk about others. Oh my God. Grab your umbrellas. You know why? It's pouring. It's pouring. Now, what's x squared raised to the 3rd? How much is that? X to the 6th. This is y squared, right? Raising it to a power. Raise the numerator and the denominator to the power, right? So, like, you see how you see a y down here? You don't see a number up over here. That's a 1, because anything to the first power is itself. So what is, oh my gosh, terrible. I'm so bad, sorry. My bad, my B. Yeah, x to the 6th, y to the 3rd, right? Because you multiply the numbers. And we'll get used to this. We're going to practice this for a long time. And finally, we have one more. Or are people still writing things down? Yep, there's one more. Oh, it's what? What's up? You need more time? Oh, because it's raised to the 3rd power, so it's like 3 times 1 is 3. That's why. And then finally we have this last one down over here, like raising a product to a power. So take a look at this last one. Suppose you have stuff going on inside the parentheses. What do? Once again, it is pouring. You got to distribute that 3. That's 5 to the 3rd times 2 to the 3rd, and then we're going to have to try and figure out how much that is. 5 to the 3rd times 2 to the 3rd is, I think, 1,000. And you could plug that into your calculator. It's 1,000. Another way that you could think of it is that 5 times 2 is 10. 10 to the 3rd is 1,000. So 2 ways to think of the problem. Sometimes one is more useful than another. Like in this first instance, we only had numbers, but in the second instance, we have letters called variables. Oh, so annoying. Let's think about what that second one could be. 4 squared, 4x squared, squared. Joe, buddy, do you know what it is? Any ideas for what it is? What? Make it rain, right? We're going to make it rain. Pour, right? 4 is the same thing as 4 to the first. Take this 2, distribute it inside. You know what 1 times 2 is? What's 1 times 2? Okay. What's 2 times 2? What's 4 squared? 16. So the final answer for this one is 16x to the 4th, right? Here's another way that you could think about it. This is going to be 4x squared times 4x squared, because there's 2 of them. There's 2 of these guys. That's what that 2 on top means. That's what this thing over here means. The 2 over here means there's 2 of them. Yeah? And so you're going to get 16x to the 4th. So cheap shortcut. When in doubt, you can always write it out.